Shielded twisted pair, or STP cabling, refers to what kind of interference? Well, first, know that STP stands for shielded twisted pair. Whenever you're dealing with like Ethernet cables, for example, RJ45 connectors at the end, you're typically going to have twisted pair cabling. And this helps with, well, we'll talk about what it helps with in a second. It is interference. There's shielded twisted pair and unshielded twisted pair. A shielded twisted pair, STP, is where you have the twisted pair of cabling and then you have like a metal mesh around it, and that helps with, we're about to talk about it. So it's not going to be jitter because this refers to various timings of a signal. This is more internal than anything like physically external. It's more on how the data is processed, so the shielding wouldn't really be related to this. We have signal attenuation as well. Attenuation? Is that how you say it? Attenuation? Let me know in the comments the pronunciation, but signal attenuation, I think of it as signal attention, because this is basically the loss of signal strength over distance. So you basically say something on this end, and on the other end, if you're talking, they can barely make out what you're saying. So that's the loss of signal strength. However, shielding would not improve this at all. So those two are out. Let's talk about signal latency. Signal latency, just kind of like the other ones, is more internal. It's a delay in signal transmission, and it's more of a concern with the end connectors. So the shielding doesn't relate to this. Just at the end, you want to make sure you have good connection. That way there's no signal latency. And that's basically the slowness, the delay in the transmission across. The last two we have are crosstalk and EMI. Crosstalk, think about if you're having a conversation with someone and someone's next to you having a conversation with someone next to you, you guys are like talking across of each other, and that's causing interference and, well, who's saying what and understanding what. It's basically what this is. It's interference caused by electromagnetic fields of signals in one twisted pair of cabling to another twisted pair of cabling. You have twisted pairs like this, and you have shielding around them. Now, EMI is electromagnetic interference, and this is any interference caused from other electronic devices. It could be your phone. That's why you put it in airplane mode when you go on planes. So the delicate instruments up front don't have any electromagnetic interference. It could be power lines, motors, radio waves, anything that lets off a frequency, but the metal shield surrounding those cables will act like a shield and it will protect it. So the shielded twisted pair cabling reduces both EMI and crosstalk. Because you have that twisted pair, think of it as putting a tunnel between you and the person you're talking to. So you can't hear the people talking around you, no crosstalk. And then electromagnetic interference, there's a bunch of electricity just floating in through the air, but if you have a shielding over it, it should be fine. It won't go through the shielding. Again, jitter is the various timing of a signal. It has more to do with clock speeds and how the data is pushed. Signal attenuation, loss of signal strength over distance, and delay in signal transmission for signal latency are three that are not our answer.